Hello and welcome to 7.5 Notes. So in our little pre-activity that we did in class, I hope you got an appreciation or discovered on your own that a trigonometric ratio is a ratio of the lengths of two sides in a right triangle. Like I said, it was a little activity that we did in class before we started the notes, and it was just so that you could discover what a trigonometric ratio is. So if you missed the lecture, the 7.5 lecture in class, you might want to come see me so we can kind of go over it, and so that you can sort of get a better appreciation or understanding of what a trigonometric ratio is, and possibly more importantly, to understand the concept that the ratio of the lengths of the legs in a right triangle is constant for a given angle measure. In other words, it's going to be the same number. That's what constant means. It's going to be the same number for any certain given angle measure, like 53 degrees or 47 degrees or 33 degrees. You're always going to get the same value. So what that means, just kind of really quickly to show you here, because I do think it's an important concept, and that our little pre-activity in class, I think, is much better than what you're going to see here, but it's something I really can't replicate right now, the pre-activity we did. So like I said, you might want to come see me. But anyway, this might be a pretty good substitute. If you have this triangle, say, and it's 53 degrees, this angle here is 53 degrees, then if you take, say for example, this length, okay, and divide it by this length, you're going to get a certain ratio or a certain number, whatever that number is, okay? And if you have this other teeny tiny triangle, that's also a right triangle. And by the way, everything that we're going to be talking about today in lesson 7.5 and tomorrow in lesson 7.6 is regarding right triangles and right triangles only, okay? So we're just talking about right triangles. But if you have this little tiny triangle, and that's a 53 degree angle as well, then even though this triangle is smaller than that triangle, this divided by that is going to be the same number as this divided by this, okay? Because they're both 53 degrees. We're going to get the same value. That's an important concept. And if it's a big, huge triangle, okay, and that's 53 degrees, then still this divided by that is going to be the same value as that little one divided by that little one, or this divided by this. So the important concept there is that if you have a certain degree measure, 53 degrees, or 48 degrees, or 62 degrees, then you're always going to get the same value. If that wasn't true, then trigonometric ratios wouldn't be useful. And the reason why trigonometric functions are useful, and the way we're going to use them and apply them in class today and tomorrow and in the future, is that we can use these trigonometric ratios to find the measures of missing sides. Like, hey, how long is the hypotenuse? Or hey, how long is the short side or the long side or whatever? We're going to use trigonometric ratios to do that. Or hey, what's the measure of this acute angle? Or what's the measure of that acute angle? I don't know what the measures of these missing angles are. So we can use it to find the measures of missing acute angles and the measures of missing side lengths. So it's pretty powerful stuff, okay? Trigonometric ratios are. So the first trigonometric ratio that you're going to learn is called the tangent ratio. And this is how you spell the word tangent. And it can be abbreviated as TAN, but please keep in mind that we always say the word tangent, even though we get to abbreviate it with just TAN, we still must say tangent. So this, you can write it like that, but you must say tangent A, okay? All right, and reading now. If you let triangle ABC be a right triangle with acute angle A, then the tangent of angle A is defined as follows. The tangent of angle A is equal to the length opposite angle A divided by the length adjacent to angle A. So the key words are tangent is equal to opposite over adjacent. Okay? Tangent is equal to opposite over adjacent. My little picture that should help drive that concept home is right here. And something that I think is very important that you need to keep in mind is that if we're talking about the tangent of angle A, then everything is in relation to this angle A. So you have to literally keep that as your point of view. What I mean by that as your point of view is, and the way I like to teach it is I draw like a little eyeball, okay? So your eyeball is like right there, and you're kind of looking at it that way. That's your point of view. So imagine that your eyeball is right there, or that there's a little tiny man standing there, or a little tiny woman standing there, or yourself as a little tiny person. You're standing there. It's all in relation to this point of view. Here's your eyeball. So that's your point of view. And so from that point of view, you're seeing that this is opposite, right? From where your eyeball is, from that point of view, side BC is opposite. So that's where I get that BC is opposite, okay? And then similarly, the side that's adjacent, if your eyeball is right here, is side AC. So AC is adjacent or right next to angle A. That's AC, is adjacent. And you might be thinking, well, wait a minute. Why isn't AB adjacent? Okay, the answer is AB is the hypotenuse. And the hypotenuse is only considered the hypotenuse. The hypotenuse is never called the opposite side, and it is never called the adjacent side. The hypotenuse is always the hypotenuse, and never adjacent or opposite. Okay? And remember what a hypotenuse is. It's the longest leg of a triangle, and it's directly opposite the right angle. Okay? So that's the important concept of putting your eyeball where the angle is. Okay? And then in relation to your eyeball, that would be opposite, that would be adjacent. So that's where you get the BC over AC. Okay?